Good afternoon to everyone. Hello.
Good afternoon, sir.
Good afternoon. Okay, we'll start. In the previous lecture of basic mechanical engineering, we covered up to compressor. Am I right? All the compressors are covered.
Yes, sir.
Okay. Now we will move to the when I think I asked you to search the video related to vane blower and the root blower. Have you searched and have you seen the animation? बघितलं का सर्वांनी? Hello. मी तुम्हाला सांगत होते की you just search on internet how the vane blower works and the root blower works. Let me I will show. Can you see? Hello.
Yes, sir.
Is my screen visible?
Yes, sir.
Yes, sir.
Just observe it how it is working. The lobes are how rotating like gear and how air is get entrapped between the lobes and casing. Okay. So like this, there are many videos related to the root blower and the vane blower. So let us play some videos related to this thing. vane blower. Can you see?
Yes, sir.
Okay, just see. Spring loaded vanes are there. See that vanes are how get compressing. So parallel, you can see the reciprocating compressor also. Okay, I hope at least through the this video, you might have understood the working of vane blower. कळलं का? समजलं का?
Yes, sir.
Okay, so you can also watch the video. Just simply Google search root blower, vane blower, reciprocating compressor. Just search on the Google and you can watch the video. So for better understanding and better clarity about that working of a vane blower and root blower. Getting. So we'll move to the next part. So next part, you can do the heading turbines. Please put the heading as turbines. Okay, give the heading turbines. Now, everybody knows that turbine is a power absorbing or power producing device. What is the type?
Power producing device.
Yes, it is a power producing device. It produces mechanical power, and that power will be utilized for running the generator or rotating the generator. So if you talk about the hydraulic turbine, means whatever the working substance that we are using as a water. Okay, so this hydraulic turbine is a machine which converts the pressure and kinetic energy of the water into mechanical energy. So if you जर तुम्ही बघितलं असेल कोयना डॅम किंवा इव्हन आपल्या इथलं जो उजनी डॅम जो आहे तिथं पण तुम्हाला यू कॅन फाइंड दी पॉवर जनरेशन प्लांट राईट त्याच्यामध्ये पण तो टर्बाइन्स यूज केलेला आहे तिथं वी आर युजिंग वॉटर ॲज अ सोर्स so that will be used for means that water falls on the turbine blades and converts into mechanical energy. So here if you see the hydraulic turbine, it is a machine which converts pressure and kinetic energy of the water called hydraulic energy. So whatever the pressure and water energy, kinetic energy, you can call as a hydraulic energy, and that energy will be converted into mechanical energy, right? And that mechanical energy again further converted into electrical energy by using electrical generator, right? So here in the turbine you can have the classification. This is what according to the head and discharge of water available. Okay, it is classified like this: high head turbine, medium head, low head. Then again it is according to the position of the shaft: horizontal turbine, vertical turbine. Then according to the names of inventors, okay, who invented the turbine. So based on that turbines classification is made. Pelton wheel, Pelton is the name of inventor. The second turbine is Francis turbine. Francis is the name of the inventor. The third one is Kaplan turbine. Okay, so this is what the classification of the turbine is made based on the head and discharge of water available, position of the shaft, then names of the inventor. So as per our syllabus is concerned, it is expected to discuss 3 turbines, that is Pelton wheel.
Slide
Still
is not visible.
okay. Now is it visible?
Yes, sir.
Yes, sir.
No, sir. Yes, sir.
No? Now is it visible?
Yes, sir. Yes,
Okay.
sir.
So just now we have discussed the definition of turbine. Turbine is a mechanical device which produces mechanical power, right? So firstly, we can talk about the hydraulic turbine. So means what? When I say hydraulic energy, it means it's a combination of pressure and kinetic energy. So that it is called as hydraulic energy. So that hydraulic energy is converted into mechanical energy using a turbine device, right? And that mechanical energy, again, it will be converted into electrical energy by using electrical generator. So then second point for the discussion is the classification of turbine. The classification of turbine is made based on the 3 factors according to the head and discharge of water available. That is high head turbine, medium head, and the low head. And second point for the classification is according to the position of the shaft. That is horizontal turbine and vertical turbine. Then third is according to the names of inventors. So we invented the turbine. So the based on the that it is Pelton wheel, Francis turbine, and the Kaplan turbine. So if you look our syllabus, in the syllabus, it is expected to discuss, or it is expected to study only 3 turbines. That is Pelton wheel turbine, Francis turbine, and the Kaplan turbine. So what are the remaining types that is based on the classification? You can study in detail in one of the subject fluid machinery and fluid mechanics and fluid turbo machinery. Okay, in that you will study in detail. Okay, different kinds of turbines with its different design calculations, etc. Okay, at 3rd year level or final year level, that you can study this turbine part in detail, right? But at 1st year level, it is expected to understand at least principal working of the construction details of a few turbines, that is Francis turbine, Kaplan turbine, and the Pelton turbine. Okay, so we'll study one by one. So can we note what is turbine? Just note down. Turbine. Turbine is a mechanical device. Turbine is a mechanical device which extract the energy from flowing fluid. I will repeat. Turbine is a mechanical device. So this definition already I had discussed long back. It is common definition. Turbine is a mechanical device which extract the energy from flowing fluid, flowing fluid, and converts into mechanical energy, full stop. Next line. The mechanical energy is further converted into electric energy Mechanical energy is further converted into electric energy by an electric generator. By an electric generator. By an electric generator. Okay. Then put the next heading, classification. So the classification, you can see on the there are three factors are considered. Point number one, according to the head and discharge of water available. Write down. According to head and discharge of water available. According to head and discharge of water available. First point, high head. High head. Second, medium head. Medium head. Third, low head. Low head. Then second factor, according to the position of shaft. According to the position of shaft. According to the position of shaft. That is first point, horizontal turbine. Horizontal turbine. Second, vertical turbine. Vertical turbine. Then next factor, according to the names of inventors. According to names of inventor. According to the names of inventor. According to the names of inventor. In that first point, Pelton wheel. Second, Francis turbine. Francis turbine. And third is Kaplan turbine. Third is Kaplan turbine. Okay, so this is about the classification, but as per the syllabus is concerned, we are going to discuss only three turbines, that is Pelton turbine, Francis turbine, and Kaplan turbine. Okay, so we'll move to the first turbine, that is Pelton wheel. Please put the heading, Pelton turbine. Okay, please put the heading as Pelton turbine, and we'll have to draw this diagram. Okay, heading the Pelton turbine, and we'll have to draw this diagram. You follow my instructions so that you can understand how to draw the diagram. Diagram काढताना मी जी सूचना देतो त्याप्रमाणे फॉलो करा. कुठून सुरुवात करायची बघा. So draw one horizontal line, that is a baseline. Okay, floor. Then by faint line, just draw two vertical lines. दोन्ही साइडला vertical lines काढून घ्या. Draw vertical lines. By faint, म्हणजे पेन्सिल न काढता तुम्ही फेंट काढायला सुरुवातीला. Draw it faint. Okay, then draw a semicircle. That is called as casing to the turbine. Draw a semicircle. Okay, so this semicircle should be drawn dark कलर चालेल. Only हे जे दोन दिसतात vertical lines इकडचा लेफ्ट साइडची ते फक्त फेंट करा, कारण आपल्याला तिथून हे काढायचंय, पाईप काढायचे, पेनस्टॉक काढायचं, दॅट इज कॉल्ड एज पेनस्टॉक. Then we have to show the runner. हे रनर काढायचं आपल्याला. बघा, टेक द जजमेंट म्हणजे आपल्याला हे असे पाईप दाखवून त्याच्यावरती ते वॉटर फॉल करायचं बकेट्स वरती. सो ड्रॉ अकॉर्डिंगली त्याचे जे काही पोझिशन असेल सर्क्युलर रनर जो आहे ते अशा पद्धतीने ड्रॉ करा की ते बरोबर पेनस्टॉक मधून ते जे पाणी फ्लो होईल ते बरोबर ह्याच्यावरती बकेट्स वरती पडेल. सो यू कॅन ड्रॉ दिस runner, dry circle, then inner circles you can draw, that is a shaft you can say, right? Then show the buckets. Buckets काढत असताना काय करायचं, इक्वल स्पेसिंग सगळं दाखवायचं आहे. You can show the buckets equal spacing. Okay, likewise you can show the buckets. Okay, so this way you can draw the runner and on which the series of buckets are placed. Then you can show the penstock where you can see the bend to the penstock. You can draw the penstock with the bend. Then you can show the spear. Are you drawing with me or not?
Yes, sir.
Show the spear. So you try to draw very logical so that you will not forget how to draw the diagram, because it is very important thing to start with the diagram. कुठून सुरुवात करायची आणि कसा एड करायचा डायग्राम, ते जर कळालं तर परत ती लॉंग टर्म राहते डायग्राम लक्षात आपल्या. And absolutely we have to go for the practice. Diagram practice शिवाय येत नसतात. This is called as deflector. You can show the deflector. Okay, this water is flowing over the buckets. Then at the top you can show this breaking jet. ब्रेकिंग जेट म्हणजे काय, हे वॉटर ह्याच्यातून फॉल होत असते आणि ते बरोबर टर्बाईनच्या ह्या बकेट्स वरती फॉलो व्हायला पाहिजे. नाहीतर तुम्ही ब्रेकिंग जेट एकदम साईडला काढला आणि ते याच्या ते पाणी फ्लो झालेलं बरोबर ह्याच्यावर पडलं पाहिजे बकेट्स वरती. त्याचं मी फंक्शन सांगतो का ते प्रोव्हाइड करायचं वगैरे. So you should take care that while drawing this braking jet, it should be drawn in such a way the water should get fall over the buckets, turbine buckets. Over. Is it over? Draw केलं का सर्वांनी?
Yes, sir.
Okay, shall we start the explanation? See this, please stop. If you are not drawn, please stop. You can draw later also. So this Pelton turbine, it is also called as impulse turbine. See, I'm using the word impulse turbine. So what is the meaning of impulse turbine? As if you see the construction of this Pelton turbine, in the dam, water is stored. Dam मध्ये water store केलं असते. Then from that dam, water is coming through the penstock. So this is the penstock through which water is coming. Okay. So whatever the energy at the inlet of this means at this junction, हे जे काही entry आहे. Okay. So whatever the energy available at the inlet means what? This is the inlet, you can say. Getting? So whatever the energy will be present, initially water possesses potential energy. When it flows through the this penstock, it possesses kinetic energy. So whatever the energy will be available at inlet, if this is the kind, then we can say it is an impulse turbine. Okay, or you can say whatever the pressure energy of the water, firstly converted into kinetic energy by means of a nozzle. So here is a nozzle. So you know that the function of nozzle. What is the function of nozzle? What is the function of nozzle? This is the nozzle. It's a decreasing area. एकदम small. सुरुवातीला बघा एकदम end ला कैसा आहे ते pipe? एकदम smaller area, एकदम दिसतो section. It is very much small. So what is the main function of the nozzle? आपण बघत थर्मोडायनामिक्स मध्ये नोझलचं काय काम असतंय?
Increasing velocity of fluid.
Correct, to increase the velocity of the fluid. If you see the cross section, inlet is the larger and exit is smaller, so definitely whatever the velocity at the entry and exit is different. So here whatever the energy, whatever the water is there, it is coming with through the penstock. Okay, so whatever the pressure energy is very high, and that pressure energy is converted into kinetic energy of the water by using nozzle. So this is called as impulse turbine. This is called as impulse turbine. So I will repeat impulse turbine. Impulse turbine means the energy available at the inlet is only kinetic energy. That is, pressure energy of the water is firstly converted into kinetic energy by using nozzle. So that is the impulse turbine. So sometime in the exam you can find the question, explain impulse turbine. Sometime in the question paper you will find the question, explain impulse turbine. Impulse turbine means काय? Pelton turbine. Can you do you understand? Pelton turbine as काय म्हणतात? Impulse turbine. लक्षात आहे का? And what is the meaning of impulse turbine? So just I told, whatever the energy will be available at the inlet is the kinetic energy, and once water flows through this penstock, so it possesses high pressure energy, and that pressure energy is converted into kinetic energy by means of nozzle. So that is the impulse turbine we can call, right? Then second kind of turbine is their reaction turbine. That will be the remaining two types, Francis turbine and the Kaplan turbine. So Francis turbine and Kaplan turbine comes under the category of reaction turbine. So that we'll discuss after this Pelton turbine. म्हणजे Pelton turbine झालं की राहिले जे दोन टाइप्स आहेत, reaction turbine, Kaplan turbine and Francis turbine. It is the category of reaction turbine. Okay, but when we talk about the Pelton turbine, it is a type of impulse turbine. Getting? So we'll discuss this impulse turbine in detail as we have drawn the diagram, where you can see the construction details. There's a one runner over which buckets are present. Turbine is like hemispherical buckets are there. Then there is a deflector, then jet of water which is striking over the buckets. Then there is a penstock. Okay, the penstock is of concrete because the pressure of the water will be very high. So to avoid the breakage or the damage of the pipe, so normally it is made of concrete, right? So then there's a spear. With the help of spear, we can control the flow of water. Whatever the water is coming from through the penstock, if we want to control the flow of water, we can move the spear forward and the backward. Okay, there's a forward and backward movement of the spear we can perform, and accordingly flow of the water can be controlled. Okay, जर पाण्याचा फ्लो जर आपल्याला कंट्रोल करायचा असेल तर we have to use the spear. Getting? Then there is a braking jet is provided at the top. So through this braking jet, water is falling over the buckets. Okay, braking jet म्हणजे काय? एक प्रकारचं ते पाण्याचं तिथून पाणी आपण तिथून सोडत असतोय ओव्हर द टर्बाइन बकेट्स. जर ते टर्बाइन रनर एकदम फास्ट हाय स्पीड ने फिरत असेल आणि त्याला आपल्याला जर स्टेशनरी करायचं असेल, त्याला त्याचा स्पीड कमी करायचं असेल, वी हॅव टू fall the water, or we have to pass the water through the braking jet. And braking jet, it is provided at the top of the casing, and through which water is flowing over the bucket at the back side of the bucket, and that it will try to come, the turbine will come to at the rest if it flows the water over the buckets. म्हणजे त्याच्यावर जर तुम्ही पाणी फॉल केलं तर त्या जे काही टर्बाइन हाय स्पीड ने फिरत असतो तो कमी होतो, त्याचा स्पीड कमी होता होता. Slowly the speed of the turbine decreases. Okay, when you pass the water through the braking jet. Right. So this is about the construction of the Pelton turbine or the impulse type of turbine. Okay, then there is also one thing, deflector. So deflector is what it does, it deflects the water toward the buckets. म्हणजे ते पाणी असं खाली पडू देत नाही. ते काय करतं, it will try to push or it will try to deflect the water toward the turbine buckets. That is the main purpose. The deflector is provided at the entry of the or at the near to the nozzle, through which water is moving with high speed. That is a jet of water. Okay, it forms a jet and it strikes over the bucket, and it will get, the runner will get rotates with high speed. Get it? So this is about the construction details of the Pelton turbine or impulse turbine. Okay. Now let us start, or let us understand the working of a Pelton turbine. आता Pelton turbine आपण working exactly कसं होते बघूया. Okay. So when water in the dam, it is stored in the dam, which possesses potential energy. When it flows through the penstock, it converts potential energy of the water into kinetic energy, and that water, as it is moving towards the turbine, so initially at the entry of this nozzle, the pressure of that water is very high. Okay, and definitely when it passes through the nozzle, the velocity of that water increases as pressure is also very high, and it forms a jet, breaking jet. There's a jet of water, and that water falls over the turbine buckets, and once water strikes over the bucket, the runner will start rotating. Okay, so that runner will rotate with a high speed. Getting? That is what we obtained here, a mechanical energy. Yes or no? So we can say we can obtain here a mechanical energy, and that mechanical energy is utilized for rotating generator, because the shaft of here is a shaft. So this shaft of this turbine is connected to the generator shaft, and it is rotating with high speed and converts into electrical energy by using generator. Okay, so this is the simple working of a turbine. Now next question may be the how to stop the turbine, or how to take this turbine to the rest. म्हणजे आपण त्याला slow down करायचं किंवा stop करायचं. How to do that? Just push this spear and control the flow, or you can stop the flow. At the same time, pass the water through the braking jet, and that water, when it starts flowing the water through the braking jet over the buckets, so steadily the turbine will come at the rest. Steadily turbine will reduces its speed, and finally it comes at the rest. So this way this Pelton turbine works, and we obtain the mechanical energy through the this Pelton turbine. Is it clear? कळलं का? मी अजून ते रिपीट करतो की पेल्टन टर्बाइन ह्याला इम्पल्स टर्बाइन म्हटलं जातं, कारण जी एनर्जी एंट्रीला अवेलेबल असते दॅट इज द कायनेटिक एनर्जी. ज्यावेळेस ते पाणी त्या ह्याच्यातून पेनस्टॉक मधून फ्लो होऊन त्यावेळेस पुढे होते पास टर्बाइन कडे फ्लो होत असते, त्यावेळेस तिथं मध्ये नोझल बसला असतो, आणि नोझल बसल्यामुळे काय होतं की प्रेशर ते वॉटर असतं आणि प्रेशर आणि कायनेटिक एनर्जी वाढते. त्यामुळे जी काय दॅट इज कॉल्ड ॲज इम्पल्स टर्बाइन. आता हे टर्बाइन वर्क कसं करतंय, ज्यावेळेस पाणी पेनस्टॉक थ्रू आपण सोडतो डॅम थ्रू, त्यावेळेस तिचं कन्वर्जन होतं एनर्जीचं, पोटेन्शियल एनर्जी ऑफ द वॉटर इज कन्वर्टेड टू कायनेटिक एनर्जी, आणि ज्यावेळेस ते फ्लो होईल थ्रू द पेनस्टॉक, at the end of the nozzle the velocity increases of that water and it forms a jet, and jet झाल्यानंतर ते काय होईल, it will flows, that jet of water flows over the buckets and strikes over the bucket, and it rotates. The runner will rotates, and due to the rotation the energy obtained or energy will be there. That energy is nothing but mechanical energy, and that mechanical energy is converted into electrical energy by using generator, कारण त्याचा जो शाफ्ट आहे जनरेटरचा हा टर्बाइनच्या शाफ्टला जोडलेला असतो. सो ऑब्टेन द इलेक्ट्रिकल एनर्जी. ओके, सो दिस इज द वर्किंग ऑफ ए पेल्टन टर्बाइन. कळलं सर्वांना? तुम्ही विज्युअलाइज केल्यानंतर सुद्धा तुम्हाला लक्षात येते हे कसं वर्क करत असेल. समजलं का? अजून रिपीट करायचंय? Hello. So whatever the water is flowing through this braking jet and it falls over the bucket, it is also called as hydraulic brake. आपण म्हणतो ना ब्रेक दाबल्यानंतर गाडी रेस्टला येते, तसं if want to slow down this turbine or to take the turbine to the rest, so you can press the hydraulic brake. So hydraulic brake is what? It is a braking jet through which you can flow the water, you can pass the water. त्यामुळे इथून जे पाणी पडत असतं ते एकदम हाय स्पीड न पडत असतं, त्यामुळे पाठीमागच्या बाजूला पडल्यामुळे बरोबर ते टर्बाइन 100% रेस्टला येणार आहे स्लोली. Get it? So like this, the speed of the turbine can be reduced by passing the or applying the hydraulic brake, we can call. लक्षात आलं? तर हा जो पेल्टन टर्बाइन आहे, यू कॅन यूज इट फॉर व्हेनेवर देयर इज अ हाय हेड. ज्यावेळेस तुम्ही मगाशी म्हटलं आपण क्लासिफिकेशन करताना हाय हेड, मीडियम हेड, लो हेड, जिथं हाय हेड असते त्या केसमध्ये तुम्ही हायड्रॉलिक टर्बाइन तुम्ही वापरू शकता. Okay, you can use high head. So for example, Koyna Dam, you can see the Pelton turbines are present over there. Okay, so normally in the hilly section, so there's a large amount of water is available in the dam, and you want to convert, you want to generate the more amount of electricity. So you can prefer this Pelton turbine. It is best one because it is used for high head. So best example of high head turbine is the Pelton turbine. Is it clear all of you? Kalaka? Have you understood or not?
Yes, sir.
Okay. Boy side. समजलं का नाही समजलं?
Yes, sir.
Okay. So shortly you can note down. Shortly. The Pelton turbine is also known as impulse turbine. The Pelton turbine is also known as impulse turbine. Impulse turbine. Next line. In impulse type of turbine, the energy available at inlet, is only kinetic energy. Full stop. Next line. The pressure energy of the water is first converted into kinetic energy. By means of nozzle. Okay. Then write working of Pelton turbine. Working of Pelton turbine. Water is transferred from dam. Water is transferred from dam to the nozzle by a penstock, comma, through the nozzle through the nozzle, water flows at high speed, jet of water, high speed jet of water, comma, this water jets strike, this water jet strikes the buckets and starts to rotate the runner and starts to rotate the runner and starts to rotate the runner starts to rotate the runner. Full stop. Next paragraph. The sphere is operated, the sphere, SPEAR, sphere is operated automatically, the sphere is operated automatically to increase or decrease the amount of water flows, the amount of water flows as per the load, full stop. The rotating runner rotates the generator and electricity is produced as it is mounted on the same shaft of a turbine, as it is mounted on the same shaft of turbine, full stop. Next paragraph. In order to bring the turbine to the rest, the nozzle is closed by a sphere, and through the braking jet water is false on backside of bucket, and it acts as a hydraulic brake. It acts as a hydraulic brake. BREAK, brake. Full stop. In the next paragraph, the deflector is provided. To deflect a jet of water, away from striking the buckets, समजा तुम्हाला लोड कमी आला असेल तर काय गरज नाही एवढ्या हा स्पीड टर्बाइनला फिरवायचं. सो डिफ्लेक्टर विल हेल्प यू टू व्हॉट एव्हर द जेट ऑफ वॉटर इज देअर, इट विल डायव्हर्ट द फ्लो, जे काही फ्लो असेल तो काय करेल, डायव्हर्ट करेल. So deflector role is very important in controlling the flow, in controlling the turbine rotation. काय लिहिलं? Deflector is provided to deflect the jet of water away from striking the buckets, away from striking the buckets, striking the buckets in case load on the turbine suddenly reduces, load on the turbine suddenly reduces, load on the turbine suddenly reduces. Next line, note, this turbine is used for high head condition. This turbine is used for high head condition. High head condition. मतलब high head किती असते? Normally 500 meter. 500 meter. High head condition up to 500 meter. Okay, so this is about the Pelton turbine, or it is also called as impulse turbine. Is it clear? परीक्षेत तुम्हाला प्रश्न येईल 5 मार्काला. जर ऑफलाईन परीक्षा राहिली तर तुम्हाला त्याचं डायग्राम काढता आलं पाहिजे. डायग्राम काढून त्याचं वर्किंग लिहिता आलं पाहिजे. लिहिता येईल तुम्हाला? हॅलो, कॅन यू राईट?
Yes, sir.
शब्द रचना तुमची जरी तुम्ही स्वतः ठेवली तर काय अडचण नाही. फक्त तुम्हाला ते कन्सेप्च्युअल अंडरस्टँडिंग व्हायला पाहिजे, ते कसं वर्क करतंय तुम्हाला व्हिज्युअलाइज करता आलं पाहिजे. गेटिंग? Again, you see watch the videos related to the hydraulic turbines. No problem. So we'll stop here for the today. So in the next lecture we will cover Kaplan turbine and Francis turbine. That will be our last lecture. Okay. So give the attendance. Roll number 1.
Present.
2.
Present, sir.
3.
Present.
4.
Present, sir.
5.
Present, sir.
6. Roll number 6. 7.
Present, sir.
8.
Present, sir.
9.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12. 13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Present.
17.
Present, sir.
18. 19.
Present.
20.
Present, sir.
21.
Present, sir.
22.
Present, sir.
23.
Present, sir.
24.
Present, sir.
25.
Present, sir.
26.
Present, sir.
27.
Present, sir.
28.
Present.
29. 29. 30. Roll number 30. 31.
Present, sir.
32. 32. 33.
Present, sir.
34. 34. 35.
Present, sir.
36.
Present, sir.
37. 37. 38.
Present, sir.
39. 40. Roll number 40. 41.
Present, sir.
42. 42. 42. 43. 43. 44.
Present, sir.
45.
Present, sir.
46.
Present, sir.
47, 47, 48, 48, 49,
Present, sir.
50,
Present, sir.
51, 51, 52,
Present, sir.
53,
Present, sir.
54, 54, 55,
Present, sir.
56, 56, 57,
Present, sir.
58, 58, 59,
Present.
60,
Present.
61.
Present, sir.
Okay. मैं absent number वाचतो once again. Roll number 6,
Sir, roll number 6 is present, sir.
roll number 12, 18, 29, 30, 32, 37,
32 present, sir.
32 present, 37, 37, 37, 40, 42, 43, 47, 48, 51, 54, 56, and 58. These are
54 present, sir.
54 present. Okay.
40 present, sir.
40 present. Okay. 37 also present.
Yes, sir.
37 present. ठीक है. One message. Any update regarding hostel or college? See, already college is started. Okay, but there is no any official document from university side related to the start of hostel getting. So there's no 100% perfect decision from government side to start the hostel in the respective engineering colleges. So there's no any perfect authentic documentation from the government side or any from university side. Whenever it will come to the college, definitely it will be shared to the all students. ज्यावेळेस कॉलेज साईडला युनिव्हर्सिटीकडून तसं लेटर येईल त्यावेळेस सर्व विद्यार्थ्यांना ते सर्क्युलेट केलं जाईल. ओके, आय होप आय आन्सर्ड दी युअर डाऊट और क्वेश्चन. 57 नंबर तळेकर.
Yes, sir.
College is started already. Okay, few students are attending the college. ठीक है. अजून काय कोणाचं?
सर ते फोन नंबर पाठवले नाही.
Yes, that work is pending because my laptop is taken by some faculty member for some form filling work, CET form filling work. So yesterday he has not submitted to me, and the college I didn't got the time. So today I will share. Don't worry. Okay. Again, I will upload the lecture, today's lecture, no problem. Sometimes it remains due to some emergency call from the office side. So it might be remain to upload, but you are reminding me, that is good thing for me. I will upload it. Okay. What are the backlog related to the uploading the lectures? I will update immediately. No problem. Okay. So we'll stop here for the today. Thank you very much.